Hey guys, welcome back again. I hope you are doing well. So let's start today's lead code and the GFG. Let's start with the lead code. Okay. So we have the, this question 3093, longest common suffix queries. We have two arrays, web container and word queries. For each web container of I, you need to find the string for each words of query, you need to find a string from the word container that has the longest common suffix with word query of I. If there is two or more strings, then share the longest common suffix. Find string that is the smallest in the length. Uh, if there are two or more such strings have the same smallest length, find the one whose occurrence earlier in the words container. Return an array of integers answer where answer of I index of string in word container that has the longest common suffix. Okay, so let's see by the example. We have a CD, the word query, right? And strings from web container that has share the same common suffix. There are three, right? 0 and 2. Among these, the answer string at index 1 because it has the shortest length of 3. Okay. So shortest length of 3. Gotcha. Now, what was it? Share the longest common prefix. Find first we need to make sure it's longest common prefix and find the string smallest length. If there are two or many, then whoever comes first, that will be our answer. For example, B, C, D. So again, three indexes, and among these, the answer will be at index 1 because it has the shortest length of 3. Okay. Now again, X, Y, Z, no string match, and okay, the comma's longest prefix is empty. That is shared with the index 0, 1, 2. Among these, the answer of the short string is index 1 because the shortest length is 3. Again, let's see. We have GH, which is common, and then shortest among these of length 6, which is at index 2. Okay. Okay. Now the length is like this much, this much. So for brute force approach, we can take any query and check the suffix with everyone. Okay, whoever gives us the longest, then that will be our answer. And the longest common prefix with the shortest length. Okay, now now what? How to do this? Okay, the first thing which is obvious of the brute force we're taking a query and checking the suffix for all, which will be n square. Uh, and then again, we have the check function, which will take the length of the string, okay, which is again 10 raised to 3, right? 10 to the power 3. So first, we need to, you know, find out about how we can check for every query, in sort of not, in sort of constant time, not constant, but you know, what I'm saying is, let's copy this and try to think about this. Okay, so we have this, right? So what if we can check for this the longest common suffix, okay, and we are not checking individually. We need to check uh, at once for all, right? So for that, we can use a try, and we'll put uh, the words from the back side, I guess. Let's say D, then we have C, then we have B, and you can see this is ended, so we can have the indexes, okay. So since D, C, and P, these are all okay. We can think about later the indexes, okay. So the B appeared, then again we have A. This is end of word, okay, end of word. And we have uh, then we have X and A. So one will be for X and one will be for A. Here again, end of word, okay, end of word. So so when we try to check for C, the first query, we'll go for this from the backside, okay. It matches. We go for C, it matches, okay. And once it matches, we check whoever's the end of word coming first. We will check this particular word's index and we'll put into it. And for that, we can do one thing, that since we are stopping at the end of word, I guess should we no, we can, for now, let's try to check, let's try to have a hash map which stores the, you know, what you can say, it stores the words indexes, okay. So for example, BCD will be at index 1, ABCD will be at index 0, and XBCD at index 2, okay. And now again it's done. So let's see what happens when we try to see the D, B, and we hit the end of word. Then just check into the, we hit the end of word and still, you know, uh, yeah, we hit the end effort and then this happens. Let's try for this. We again hit the end effort. Let's try for XYZ. So there is no match for XYZ. We can have the suffix, uh the shortest length, right? We can see the shortest length is this one, right? So again, if there is a no match, we have to go for the shortest length. But there might be one confusion. Let's say if there is no match, okay. For example, what was this? XYZ. Let's say if it has E, F, let's say. So XYZ no match. So where to go for this or this? Okay. This might be confusion. And yeah, we have to think about that also. So meaning when we go at this point, this this is the shortest, right? When we go at this point, this is the longest. So how can we figure out where to go? Okay, how can we figure out where to go? How? So when we are putting the word, I guess we need to put the length of the word also. Okay. For example, when we are trying to put BCD, we have to put the length. So, and we always try to, uh, you know, put the shortest among these. Like, for example, when we try, okay, when we try to put ABCD first, okay, this letter comes, then D. The length of this 0, 1, 2, 3, 3, right? So, the index is 3, but the length is 4. So we'll put fourth, and then fourth, and then fourth. Okay. Again, the BCD comes. So, that this D, the length will be 3. So this will be 3. Okay. Again, we hit this one. The length is 4th. So we'll keep the smallest as it is. So the D as it is, C as it is, B as it is. Then for X, we can update to the length, which is 4th. Okay. So to get minimum, we have to initialize with the, let's say, int max uh, initially, then we'll update to the minimum. And now when we have CD, let's say C and then D, these D and then C, then it will show the length 3, right? So you can put directly the index into it. Since it's not asking, uh, yeah, like this way. So when we hit XYZ, then you can see there is no node of X, but there is only one, which is D. So let's put the length of D into it. And yeah, also we can have the index also from where this length came. Okay. So this came from index 1, this came from index 1, and this also came from index 1. Okay. And when we are updating, and then we update the index also. Let's say we reach again the shortest length 3. Let's say again sort of we hit this. then we'll update to it. Okay. So yeah, let's try to think about this. Okay. This looks good for me right now. We'll check what happens later. Okay. So, our node will contain uh, first, you know, index, okay, then int length. Okay, we have the index and then length. And again, we will be having node, okay, which will be child. This is how the tree node works, right? So, yeah, this is our node, and we need to just insert the words into this, and then yeah. But again, we are uh, yeah, this looks cool for me right now. Let's try to code. We will have try node, which will have int length, then try node child, okay, then try node. When it contains, we can have the child new try node of 26. Let's say, yeah, it contains only lowercase. Okay, and we'll have try node if it's giving the index is this is just safety purpose. This first content into the constructor. Now we need uh what we need now. We need the insert, right? Void insert. So we'll have string word int and word dot length. Okay. So for character from word dot to array, we have this character. Now we have to check this character is present or not, right? So we need try node root also. Okay, so try node temp root. Okay, so if temp dot child c of a, that's, let's see, this is the index. For this index, there is no null, meaning we have already something and something at this point. So we have to check for the length, right? If temp dot child of index dot length is greater than the IDX, the n. If it happens, then we'll update our length is equal to n, and we have to also update our index, which will be this word's index. So actually we need the index also at in which index this particular word is present. Okay, and in else part we actually don't have to care about it, right? So else, okay, so okay, else there is nothing at this point, right? So what to do at that point? Temp dot, temp dot child of that index is equal to new title, and we have to pass our index and then length, right, which will be n in this case. So if not null, we have to again temp is equal to temp dot child idx. We have to do this, right? Okay, temp is equal to temp. Let me see this is good or not. So if there is something, then we have to check that length, and if it's greater than update it. And again we are having forwarding the pointer to the next child, and here we are creating the new try node. Okay, and I guess this looks good. So at last uh temp dot, okay, we actually don't need the this looks good. Okay, maybe this might contain errors, we will check later. Okay, now void what we need now, smallest length, right? Void search. So we will have string query. Okay, and again let's this will contain index, right? Okay, so we need for in no, from character c from query dot to have array. Okay, if query, we can check later. So okay, for now I'm assuming that there is something in the query. Okay, there is some content in the query. Then we need root also, right? Try node root, then try node temp root. Again temp if temp, let's calculate the idx, which is the temp of idx dot child. Okay, temp of idx of child is not equal to that. Let's say we will have the result index. Okay, let's put 0 for now, and temp dot child IDX temp dot index result dot index. Okay, and again we are passing pointing temp to the next. Okay, and return result index. Let me see. So we are getting the index, and from if checking that, the child is not null. If not null, then update the index. And okay, it might happen. If not null, then we are updating it. Okay, to the next. And yes, at this way, we can get the longest common suffix and then the shortest, the index, shortest word. So here, before searching the query, we can put some sort of put, the shortest length index. Okay, we can have like now it's 0. And for int I is equal to 0, I is less than 26 plus I. For third dot child root dot child. Okay, I will be back. Give me a minute. Okay, I'm back. Sorry for that. So where we were? Okay, so great. Let's know this. Okay. No, okay. Let's think like this. Search. Okay. Right now, there is one problem that I am able to see right now. Let's understand. For example, we have a query BCD. Okay. B, C, and D, let's say, and this is the query, right? Let's say in word container this not contains. Okay, so in that case, what to return? The shortest among these, right? So before inserting, we will make sure that the shortest will store somewhere. Okay, and according to it we will update here. So that is what I okay. So let's start with any index, and we are trying to update the index since we need the longest common suffix. So when we reach this, okay, then returning this one. Okay. Now, while inserting our word, we will maintain our main mean the shortest word here. Okay. So for string word, we need indexes. Word container dot length plus plus I, and if word container of I dot length is lesser than shortest word length, then shortest word length is equal to this length. Okay. Now the shortest word length, let's say max value for now, and so why we can insert here also, right? Insert this word container of I. Okay. And also make sure that the root is created starting from null. Insert. Let's say if root is null, then there is no child itself, right? So we need to create at least root. So try node, which will have no index and anything. So again, let's okay, try node, and we'll pass this root to this insert after, right? And then index, right? Once we insert it, then look for query string query from query words query, and we'll have the answer, right? Answer new int, which will be words query dot length. Okay. And let's put some sort of words query dot length ans of I b. First check if it's empty. If it's empty, is empty. Okay. And even though if it's not empty, this one goes here. Okay. So we should have -1. Okay. So instead of checking here, we can directly, if it's empty, then let's try search for word query of I, then int, this will be our index, and index is equal to -1, meaning we did not found any, then we can have the shortest length. Okay, that's minus I will be index, let's say, and then return this thing. Okay. And now let's see what are the errors. Search. Okay. So in the search, we're supposed to pass root also. Okay. Okay, what happened? Temp.child. Child. Okay, here we need to do this. Okay. Child, and when we create root, new try node, then it creates the array of this, and then when we pass the root, and then if it's equal to null, then let's see. So this is our stuff coming. First cd, okay. When cd inserts, then at this index there will be null value, then we put things into this. See, okay, we got. Okay, so this is for suffix, right? So we need to fix this. We need to insert from the backward, right? So yeah, we can have the loop character, but from the back, int I is equal to I is less than n plus I, and we need s dot this word dot char at n minus I minus 1. Okay, and again here for query we need to do this. Query dot length. Okay, we need to put from the back. Again, we have 1 but for this the length is 3. Since this x is not found, okay, so for search, when we try to search for x, this is null, then it returned -1. Okay, let's check what it's returning. Index. Okay, see, -1. So if it's -1, we are putting the shortest word length. which is 3, but we actually don't, we need that index, right? So shortest word length index. Initially, let's put -1, and when we have this, okay, then we update our length I, shortest word length index. This will be this. Okay, so let's try. The one case pass, then another fail. For this one, the answer is 0. Okay, GH, then F we found, then there is no E, but we since found the F. This F should contain the length of this. Okay, while searching, for ACV, okay, in we try to find H, which among 3, then we find to get G, which is all present in all 3, then we find F, which is present in this one only. Okay, then we find B, which is nowhere. So this word's length uh, should be returned. Where is this? That word's index. So we have the index and then word. So okay, when we found F, then this is the I actually need to know this is what we are getting. So while searching, okay, I will make sure that system out dot print ln this character. Okay, and again when we hit this character, I need to know plus okay index. Okay, instead of temp dot index, it should be like okay, something like this. Okay, for the this one, the answer is 0. G, then E. Okay, H present, G present, E also present. like this, E also present. No, this is there is F. Okay, so H is there, G is there. When we are H, now for H next, so we are probably messing with the search. Okay, so we have root and then root's child, which will be our these characters. So if H is there, then update the index of it. Okay, child of index. I'm not. I actually need to know what is happening here. We need to print system. Print that then query dot this thing. So first, we have hg h this hg, and then this hgf, and then hgf. Okay, we should break. If not, okay, this is what we were messing up. Then let's try. Okay, so it's running. So we forgot to break. Let's try to submit. Accepted. Ah, ओ भाई इतने में ये हो गया भाई मेरा. Let's try GFG. What is this vertical sum? Okay, we need vertical sum 4, 2, then 5, 6, which is 11, and then plus 1, 12. Okay. So one thing is clear that if we able to find out the vertical nodes, then we can have the sum of it, right? Let's have the, you know, map, let's say, for integer, which will be our column, and then let's say when we traverse, we'll hit the columns, right? Then yes, we will have integer, and then is it maintained to, yes, from the rightmost line, leftmost to the rightmost. So we need tree map. Okay. So what I'm thinking is this we will pass 0, 0, which is our root node. Then this 0, 0 meaning the row and column. For now we are at 0, 0. When we go left, then we are adding one row and minus one column. We go in this direction like this, minus one column. These are the columns. So, and we'll add the values of the columns if it's present in the tree map. Okay, for example, let me get, okay, for example, uh, let me erase this. Okay, now for one, we have 0 comma 0. Okay, let's say 0 comma 0, and this is our root. Okay, and this is our function. So we pass this to the whatever traversal. We can go the left and then right. Okay, so we'll go for root, and then plus 1 minus 1. This is the row and this is the column. Okay, again we pass the root for plus 1 and plus 1, meaning in this direction 1 comma 1 minus 1 comma 1. Okay, and we'll store this value on the map, okay, as a key, and then this will be our value. So for now 2, and when we were at 1, so it is 0 comma 1, and then we reach minus 2 comma 2 at this 4, then this is what we will have on the map. Okay, when we go in this direction, this will be like 0 comma 1, right? So since this 0 column is there, right, then we can just add that value into it. Again, when we go in this direction, so 1 comma 1, is 1 there? No, add 1 and the value, then again go this direction, 2 comma 2. So 2 comma 2 is not there, put the column 2 and then value of it. Then when we go at this direction, which is 0 comma 2 comma 1, 2 comma 0, this is the row and this is column, right? So a 0 is present, we can add 6 into it, and at last we can have this 12 4 3 7. We will just get the values from the tree map. So call to nodes, let's say new hash on the tree map, and when we have tree map, then let's say void solve, which needs this tree map root, and then row column. Okay, so actually I think we don't need the column, either the row also. Okay, and then we can, if root is equal to null, we can return. Otherwise, solve call to nodes, then root dot left, and then code. Okay, code minus 1, and map the call to nodes dot put this call value, and then call to nodes dot get or default its previous value or 0, and then plus root dot data. Okay, and we same do this call for the right, and this is column plus 1. Okay, so this is how it works. And then sort all the nodes root and from 0. Okay, and we'll have this array list, right? Array list, a list of integers. So probably we can do like result is equal to nodes dot values return result. Let's see what is this equal to values collection of integers. This is collection of integers. Uh, okay, one thing we can do is int okay, it's passed. Great, it is also done. So thank you for the watching. Okay, bye bye.